All right, so it's great to be here. Thanks for being here early in the day. Also, thanks for, especially if you're not staying in this hotel, for facing the rains. Good on you. So what I'd like to do today is somewhat political in nature. It's also scientific in nature, and so we'll mix opinion and politics and science. Bear with me. So let's see if we can get this to work. So, right, to start off, this is joint work and based on joint discussions that have been going on for quite a while with a number of colleagues and students, both in Amsterdam and elsewhere. And I'd like to acknowledge all of them because those discussions help. They make an individual much smarter than the individual can be by him or herself. Right. So the agenda is, I'll start with a little bit of background and then spend a lot of time talking about going beyond that background, 3 directions going forward, and then I'll spend a bit of time on what we in Amsterdam are actually doing based on those ideas on those 3 directions. All right, so background. Recording in progress. Okay, supportive technology, good, thank you. Accuracy. As a community, as a search community, as a data mining community, we've been looking at different ways of evaluating the technology that we build probably since day one. And it's a large part of our community is devoted to thinking about this, developing new methodologies, critiquing our ways of working and making it better, making it broader. Certainly, for a large part of our early history, our focus has been on accuracy-related metrics, looking at the results, seeing how, in some sense or another, how accurate they are. And what we've also seen, going back already probably 2 decades, is looking at broader aspects of utility, looking at the user experience, broadening out to things like coverage or serendipity or engagingness. And more recently, we've broadened out even further, looking at different notions of bias, of fairness, but still very much oriented around utility-based ideas and goals. Now, over the history of our field, looking back, there's a bunch of great perspective papers, position papers, sort of landmark papers that said, okay, this is where we are, folks, with our metrics. What should we do next? And so there are many of them. I've just picked out 3. It's not because they're the best or the others are worse, but it so happened that these 3 are 6 years apart from each other. But there are many. You could have chosen others. And so there's a paper from 2010, Beyond Accuracy, evaluating recommender systems. There's a paper from 2016, Diversity, Serendipity, again looking at beyond accuracy objectives. And then last year, a paper on fairness in information access systems. So not just search, but also recommendation and beyond. And so I want to dive into these 3 papers very briefly, and then I want us to take a step back. And so going to that first paper from 2010 by Mao Zizhe and others. So beyond accuracy, evaluating recommender systems by coverage and serendipity. And so what they say here, and this is a verbatim quote, accurate recommendations may not be the most useful ones to the users. Evaluation metrics should take into account other factors. And then the factors that those authors zoom in on are coverage and serendipity. And coverage they define as the percentage of items for which a system is able to effectively generate a recommendation. So how much, as a user, how much of the catalog can you get to see? With a reasonable amount of effort. And serendipity, how much as a user you can be confronted with items that are attractive to you and that are surprising to you. Now then, this the second paper from around 6 years later by Kaminskas and Bridge, they step back, they do a survey of these types of metrics. So accuracy as a starting point, but then beyond that, diversity, novelty, coverage, serendipity. And they do a very systematic listing of definitions, of methods that optimize for these different metrics. They also do a ton of offline experiments on comparing state-of-the-art methods under these different metrics. But it's all still very much utility-oriented. Now then, last year, Michael Ekstrand and colleagues published this FNTIR paper. It's a survey on different notions of fairness and different ways of dealing with and optimizing for fairness in information access systems. Again, search, recommendations, a little bit of dialogue systems, but mostly search and recommendation. And again, quoting them directly, the key question that they're interested in is, are the benefits and resources, so again, emphasis on utility aspects, that a system provides fairly allocated between different people or organizations, the system affects. Does it introduce or reproduce harms? Okay, that's not necessarily utility-oriented, particularly harms distributed in an unfair or unjust way. And of course, they do acknowledge, the authors do acknowledge that when you think about fairness and when you think about doing interventions to improve fairness, you're also addressing questions that have to do with different notions of bias. And the authors touch on different notions of bias, both statistical, so systematic discrepancies between the data or outputs and the underlying world, observable world, and societal notions of bias in the form of systematic discrepancies between the observable world and the arguable ideal world. Okay, so here's something that's not maybe directly utility-oriented. Some idea of what a world maybe should be, and the discrepancy between what our systems do now and this more ideal world. And so the question that I'm interested in is, a lot of this work still is, except for this quote that you saw at the end, a lot of this work is still very much utility-oriented. It wants to improve utility for the system, the platform, the system owner, the users, different groups that make use of the system or the platform. And I'd like us to think about other things than just utility. And so I want to discuss three directions that are not necessarily utility-focused or utility-based. As I said, it's going to be somewhat political every now and then, somewhat it's about values, and so it can be political every now and then. Where this started was in thinking about what my country, but different countries in general do, 10, 15 years ago around digital development, but now the last couple of years mostly around AI developments. And so these sort of plots you'll see show up once a year, once every 2 years or so, by different policy institutes looking at how well countries are doing on different metrics around technology adoption, technology development, technology ownership. This is a plot taken from the Brookings Institute. I think it's just over a year and a half old. It's a highly dimensional problem, right? The technology development, technology adoption. They've mapped it to two dimensions, technology dimension and a people dimension, and they've then mapped the countries for which they have data onto this on these two dimensions. And you'll see countries that do well on the people axis. That means training, education, inclusion, taking everyone on board, leaving no one behind. You also have countries that do really well on the tech development. And well, my country, the Netherlands, is here. It's okay-ish technology-wise. It's not doing so well on the people dimension. And so one of our ambitions, myself and a whole bunch of colleagues around the country, was to make this move. Right, so what does it mean to make that move? Well, for us, it meant adopting a slogan and then working towards this slogan. Right, it helps to have a slogan that's easy to explain because you need to get many people on board. It helps to have a simple slogan. This is a simple slogan. It helps to, even though it's very simple, it helps to actually break it apart a little bit. And so there's first of all this, making AI, building systems, and then thinking about what these systems and this technology should do. Should it be built to replace people or to help people, to augment people, to support people? For whom? Right, for everyone. Not just a few tech-savvy people or a few rich people, for everyone. And who should be involved? So here's the S, the us. So many voices should be involved. So that's what the rest of the talk is going to be about. Making AI, not to replace people, but to augment people. That's the make AI. For everyone, that means shared ownership. So it should not be centralized. It should be in the hands of many. Everyone who's affected should have a voice. And pluralism. It's not just one voice, but many voices. And so what does that mean, this set of values, or this maybe political statement? What does it mean in terms of the work that we do, the engineering that we do, the science that we do? That's what I'd like to make concrete. This is not just going to be sort of reflections from the sideline, I hope, but also concrete examples, and hopefully also helps you going forward. Don't just go for the leaderboard. There are other values that you can go for. So we're going to go through these 3 bowls. When did we start, Hadi? For me to do timekeeping, when did we start? 9:05. Okay, good. Right. We're going to go through these 3 bowls. This is the first one, hybrid intelligence. And so the political statement or the value here is don't build stuff that's meant to replace people. Don't build stuff that you evaluate by going for human parity. Augment human capabilities. Help them do what they would not be able to do without the technology. Help build environments where people and machines can work together and together do something that neither of them separately could do as well. And along the way, create new tasks, new things we haven't thought of, create new opportunities for people to grow and to sustain. And so I want to give you, as I said, I want to not just reflect, but also give you concrete examples and suggestions for real engineering and science work. And so the rest of the talk will have this format, right? So there's the political bit and then examples, and then a political bit and then examples. And these examples are papers that some of us in the room have written, papers that I think are worth pointing out as inspiring starting points. So here's one that came out of an internship at Microsoft a few years ago. It was published at ITSCAI in 2020. It's called, it couldn't be better as far as I'm concerned, Learning to Complement People. Learning to complement humans, sorry. And so what it tries to do is look at the problem of optimizing the combined performance of people and machines by looking at their distinct abilities, people's abilities, the machine's abilities, and it So there's a machine learning problem, and then there's a few test scenarios where the solutions are tested. One has to do with scientific discovery, the other with medical domains. And of course, if you are into this, what you'd like to understand is, where do these combined hybrid teams outperform human teams or machine teams? And what makes them stronger? What makes them maybe more resilient? And so the learning problem, I hope this is visible also in the back. The learning problem that that paper addresses can be sort of distilled into this orange bit. So you're looking at the sum of a query policy function Q that decides whether to give a task to a person or to a machine. If you give a task to a person here on the left, then the utility is based on well, the cost of the human effort, and then the machine using this for its prediction. And on the right-hand side, if the query does not assign a task to a person, then you simply have the utility that the machine brings. And so what the paper does is looking at this learning problem, coming up with different differentiable approximations of the learning problem. And then it looks at two tasks, a scientific discovery and a medical task. For the scientific discovery task, they look at one of the many citizen science projects out there, where citizen scientists label lots of data. And you probably know of citizen science projects in tons of areas, ranging from counting birds in your garden to looking at the sky, classifying images of different snapshots of the sky, labeling those, classifying those. And so that's the data set that this Microsoft team used, labeling images of galaxies, one of 5 classes. The ground truth, so most of the images here were labeled by dozens and dozens of volunteers, and dozens means 40, 50, or even more. In their experimental setup, what they did is take one human response as a label assigned by a single volunteer, so that single volunteer may make mistakes. And then the total loss is the classification error of the combined labeling task, human and machine, plus the cost of queries sent to humans. And of course, as you would expect, what they found is that a joint model where they jointly optimize for this problem that I showed a few slides ago, that outperforms other types of other ways of approaching this, where you would first learn a model only on the machine side of it, and then optimize for the query prediction. What's also interesting is that if you look at where the mistakes are being made, this jointly optimized approach manages somehow to identify images that are harder for machines and give these to people. Now, a very natural follow-up experiment here would have been, okay, what are tasks or images that are more interesting to people that you should typically assign to them? What are ones that are less interesting, or where they don't like doing it? That would be very natural follow-up work that the authors didn't do, but I think it's a very interesting example. I'd recommend that you go look at their paper. They actually also reference tons of other similar experimental setups of optimizing joint human-machine teams. Now, a year later, we ourselves at Amsterdam looked at a similar setup for evaluating dialogue systems. And this was a setup that was specifically trying to reduce human effort, not because we wanted to spend less money on crowdsourcing, but because this was about detecting malevolence, so nasty utterances in dialogues, whether human-generated or machine-generated. And so the fewer times that we had to expose the nasty, malevolent utterances to people, the better. So the more of this we could hand over reliably to a machine, the better. But we still wanted to do good evaluation, end up with a good labeled data set. Right, so we came up with this collaborative framework to improve the reliability, but to reduce, not for economic reasons, but for other reasons, the human effort. And so we cast this problem as a sample assignment problem. Each time we saw a sample, so an utterance or an entire dialogue, decide whether to give that sample to a human for labeling or to rely on the machine. And of course, again, our goal was to get good quality labels, but also to minimize the human effort. And we decomposed the problem into 3 steps. One is, first of all, look at how confident the model is. Then how much human effort would be involved. And then decide whether to go for the machine labeler or the human labeler, while maximizing confidence in the outcome and minimizing human effort. And so, well, I'm not going to go into the details of each of these 3 steps, but this human effort estimation step, I'm zooming in on here. And so trying to understand when to decide to give, or what the human effort would be. We identified a lot of features of dialogues, of utterances. We also identified a number of features related to the workers. For instance, their test score on some held out data, their approval rate, short-term or long-term, and that used this as input, and then measured how much time was spent by people and how reliable the labels were at the end. And so what we found was that we could, through this collaborative evaluation setup, we could reduce human effort by a lot, while almost maintaining the same quality. So on these different reliability metrics that I mentioned. What were some of the features that mattered here? Well, features that related to the dialogues, the utterances, how long, how many, also the complexity of these utterances in linguistic terms, etc. The typical errors of the combined hybrid team, usually had to do with us wrongly assigning a task to the machine when it should have been assigned to a person, and that happened when the language usage in the dialogues was non-literal, or when we were early in a dialogue with not a lot of context yet. So this makes sense. And so let me wrap up this part of the talk about hybrid intelligence. So I gave you 2 examples under this umbrella. So let's augment human capabilities, not replace people. Let's not go for human parity, but let's go for team effort and optimize that. So that's about collaboration. And I gave you these 2 examples. Okay. The next one, shared ownership, right? So remember, let's make AI for everyone. This is about the for everyone part. So the starting point here is the observation that intelligence, becoming smarter, is not something about individuals. It's not about something that's autonomous. It's actually about the collective. The reason we come together here is because we get smarter, we get inspired, we get better by seeing each other talking about ideas, right? We don't get smarter by just sitting at home. Even Zoom helps us get smarter because we interact, we communicate, we bounce off ideas back and forth. And so that's very much behind this idea of shared ownership. Doing innovation together, putting together research agendas together, owning it together. That also means, if you build systems that are meant to serve them, don't alienate them, get them on board. It also often means that you need to find complex mixtures of policy development and tech development. So again, let me make this more concrete and more actionable. I'll give you 3 examples. This is work that's under review, so it's redacted. So here the problem is, and again, we're under the umbrella of shared ownership. This is about making sure people still own their data, their own interaction data. And so it's about developing technology that would enable this individual ownership. So in the EU, we have something that most of you will probably have heard of by now. GDPR requires organizations to delete personal user data, including interaction data, upon request. And again, quoting from the GDPR, this data subject shall have the right to erasure of personal data where the data subject withdraws consent. Now, the problem is today, if you want your data removed, it may take up to 2 months. Because, well, it's somewhere in a cloud, models are trained on it, and maybe the next time the model is retrained may take a while. And that's, wrong direction. And that's problematic, right? There are many well-publicized cases where sensitive data, people-sensitive data, stayed visible for too long, making them get, blocking them from certain options, but also making them get exposed to stuff they should not be exposed to. Because a system thought that because of their interaction data, they were interested or relevant to a certain offer. Okay, so what you need here is timely unlearning capabilities so that you can delete interaction data fast, and you can adjust your predictions on demand without having to retrain gigantic models. So fast is a keyword here, and exact. And so in this redacted paper, what we do is we offer an in-memory index structure and a way of rapidly removing interaction data. We're assuming that we're dealing with sparse interaction data sets. And so it's just 4 steps. You update your list of interactions, you update your counters. You remember, we're dealing with sparse data. You recompute dot products where the deleted interaction played a role. Then you inspect, and where possible, you directly update any top K entries. And then if any recomputation needs to be done, that's what you do. But then that's usually very, very limited. Okay, does this work? Well, there are 2 questions to this, right? It means, is it fast? Is it exact? And so building this index is competitive, even though we need to do a little bit extra. It's competitive. So here you see some plots, the top plot on indexing time, on a number of open data sets, Movie Lens, Last.fm, Spotify, Yahoo. Unlearning, can we do that fast? Yes. median latency of less than 100 milliseconds for all data sets, except for the Yahoo data set, which is bigger, but even there, it's, if I remember correctly, I don't remember the number correctly from my head. No, I can look it up after the talk. But also, does it actually work? Do we actually remove the right stuff? Do we forget the sensitive interactions? We do. On most of these data sets, the success rate is for deletion is 100% or 99%. Okay, so fast and exact. Good news. But we still have some work to do on scaling to much bigger data sets. Okay, second example. Again, we're still on the topic of shared ownership. So this was individual ownership of people owning their data and technology facilitating that ownership. The second one is on decentralizing foundation models. So there's been a lot of talk about these foundation models. There's been a lot of talk about open science around this topic, about open models. Here's a paper that tries to address open compute. And so that was put on archive, if I can read it correctly, June last year. And so it's a team from ETH and Stanford. And so what I look at is this problem of training foundation models that may take tens of thousands of GPUs running for extended periods of time. Some numbers that they quote for GPT-3 with 175 billion parameters of $4 million worth of compute, even for smaller models with 1.3 billion parameters, requiring 64 decent GPUs running for a week, costing around 30K. The question that they're interested in is, can we leverage much greater amount of decentralized, heterogeneous, and lower bandwidth interconnected compute that all of us have in our institutes or on our laptops at home and maybe in our bags right now? And of course, we do have that compute, and it's a lot cheaper. However, the models that we know that can sort of support the type of parallelism that you need for foundation models with these vast numbers of parameters. Those models are designed; they're tailored for data centers, and I guess few of us in the room have their own data center, and so these are not methods that help us. We need different methods, and that's what this paper tries to address. Right, so they're all into decentralization, take advantage of the devices that we do have, but they're on heterogeneous networks with slower connections, with maybe not completely reliable connections. And so they need to also think about different forms of parallelism that go beyond just data parallelism. So that's what they do in the paper. The communication cost of data parallelism, but also the communication cost of pipeline parallelism. That's what they look at. And what I think is inspiring in the paper is also ways that they look at different, very subtle types of optimization. For instance, hiding communication within a computation so that you can avoid it because you're working on slower connections. And then what I also find fascinating about the paper is the different types of experiments they run. So they run experiments on in a single data center, on a small number of data centers on the same continent, on multiple data centers across 3 continents, 8 regions. And then they look at the method that they've developed and how much slower it is than running one of the state-of-the-art parallelism models on a single site, a single data center. Oh, what they don't do is change the model, change the GPT-3. They try to keep that exactly the same. And so their prototype in that really heterogeneous global environment is only between 2 and 4 times slower than state-of-the-art in data center. Although the network could be 100 times slower than in the data center. Now, what they haven't done yet is train a system to convergence. Instead, what they've done is run partial training and each time confirm that the intermediate results in these different setups were the same. And so that would be an interesting follow-up experiment or set of experiments. What about training to convergence? What are differences in such a heterogeneous setting versus in a homogeneous data center setting? A quote from the paper: decentralization and democratization of the training of foundation models can shift the balance of power positively. I think that's an important quote, and to me, it perfectly summarizes the value of this paper. Okay. You're still doing okay? And we have about 15 minutes left? Good. A bit more politics now. Hard choices in AI. Now, many of us have an engineering background. So if we're given a safety measure, then how do you make sure that you meet the safety measure? Well, that's what your training, your education, your experience has prepared you for, right? If you know what the safety measure is, then you can engineer for it. The problem is often we don't know what the safety measure is. We don't know what the harms are that we want to avoid. And then, of course, there are different ways of dealing with this. One is to just ignore it and build stuff, put it out there, and we'll see what happens. Or you can deliberate. You can try to understand what the context is, what the politics are. And that often starts with just building a shared vocabulary and also identifying what the difficult choices are that you need to make. Now, this paper here, published in the AI journal 2 years ago, 2021, Hard Choices in Artificial Intelligence, gives a very tangible way of first of all, identifying this shared lexicon, but also listing the hard choices that you need to confront. You, us, we as with a technical background, but together with other stakeholders with different backgrounds. And so the hard choices are often about what we feel we should support from a societal point of view, and on the one hand, and on the other hand, what we can support from a technical or engineering point of view. And the paper offers a framework that tries to map these problems into something that's reasonably tangible for designers, engineers, and other types of stakeholders. It looks at socio-technical aspects, so inclusion of different perspectives. And of course, we all know if you get everyone on board, then you'll never finish the design. Versus coming up with a reasonable set of requirements, coming up also with a process to revise the requirements as you go along, as you see what happens when you put the system out there. A second dimension that the paper confronts is featureization. So which features should we include, which ones should we exclude, which features are likely to be misspecified, what are the costs in different financial, but also societal terms of making mistakes in determining those features. The next dimension has to do with very familiar one, optimization. Are we building the right system, and are we building the system in the right way? And the last one is is a dimension that has to do with integration of a system, of the future system in a societal context. So if this is adopted, what would be costs for people to opt out? Would they be excluded? What would be the potential for them not to opt out, but to force a change somehow? And what the paper argues for is, think of this beforehand. Think of this before you put the machine, the system, the service out. Right, so let me wrap up this part of the talk. This was all about shared ownership with 3 different examples: individual data ownership, us as a collective owning or being offered the ability to own very large models, and us as an even bigger collective with different types of stakeholders owning systems as they're being created. This was all motivated by the statement that intelligence is not about autonomous agents, it's about the collective. It's about shared agendas, about shared ownership. It's about participation of people, and it's about tech development alongside policy development. So last one, many voices. So remember, let's make AI together. Let's make AI for everyone. This is about the let's, the us. Right, so this is, again, a bit of politics, and then I'll make it more operational. Steering away from centralized control. To really get many voices around the table, what you should require is that if technology is put out there, then you directly address the impact of that technology. You don't leave it to others to solve any problems that the technology might bring. It's not for the policymakers or society in general to just fix tech problems. It also means that we need to think about different sets of metrics that are not just about accuracy or leaderboards. In the previous parts of the talks, we already saw quite a few metrics that deal with this, metrics that try to capture how effective a team is, for instance. But we can be more creative here, and I'll give you a few examples. Some examples, types of work that I feel fit nicely under this space of pluralism, many voices around the table for tech development. This is a paper that, if you can time travel, you can see at the poster session last night on generative slate recommendation with reinforcement learning. And so what the paper tries to do is try to find a balance between actions you need to take next and the long-term consequences that these actions might have. It does it in a very concrete setting, namely recommendation setting. And so these long-term effects could be detrimental, right? If you just keep recommending the same types of items over and over and over again, your users might get bored, or if it's in a societal context, then you might end up in filter bubbles or echo chambers. And so what the paper offers is a way of balancing exploitation and exploration, so sticking to known interests and exploring new interests. It still does this with a very utility-oriented frame of mind, but it does try to balance short-term and long-term. Now, the experiments that we ran in this paper, we can't really run in reality, so we ran them in a whole bunch of simulated environments, where we also came up with a way of modeling the long-term effect. In our case, that was boredom. And then we tried to understand how the different model choices and parameter choices of our models would affect these long-term consequences. I hope this is visible. These are different models and model settings. Some of the models are really almost greedily going for the next, in the next move, going for the best options. Other models towards the right-hand side, where you see less orange, that means less boredom. They are willing to sacrifice a little bit of very short-term return so as to get better long-term return. Now, this next paper actually generalizes this idea. It's there's a line of work at the interface of economics and more theoretical sides of machine learning that looks at performative prediction. And so when predictions support decisions, they may influence the outcome that they're trying to predict. And such predictions are called performative, right? The prediction causes change in the distribution of the target. Often, and I'm sure you've come across this, often when we ignore those changes that we bring about, we'll say, well, there's a distribution shift, let's simply retrain. And a fairly well-known example of this is in banking, predicting credit default risk. So if you think that someone has a higher risk of defaulting on their credit, you might increase their rates. And because you increase their rates, they actually have an even higher risk of defaulting on their debts. So what the paper tries to do is, and this is a paper was published at ICML, if I remember correctly, 2020, yes, by Perdomo et al. I highly recommend it. What the paper tries to do is make sense of the fact that you actually want to arrive at a certain equilibrium where the model is optimal for the distribution that it induces. And so you can think of these equilibria as stable points of retraining. So under retraining, these models should be invariant. And then under what conditions does the retraining converge? And when do these stable points actually also correspond to having a good performance? And so the paper comes up with this notion of performative risk to evaluate model parameters on a distribution over features, over outcomes that results from decisions according to the model. And of course, the challenge here is that the distribution itself depends on the argument, on the model parameters. One way of solving this problem is to think about it as a kind of a fixed point problem. So you repeatedly find a model that minimizes risk on distributions resulting from the previous model. And to go back to our paper from last night, you can actually think of that paper as a specific type of an instance of this ICML paper. You can think of reinforcement learning as a case of performative prediction. So the choice of policy affects the distribution over the states you visit, over the actions you take in an MDP. And repeated risk minimization you can think of as a form of policy learning, where an agent first collects a batch of data under a particular policy and then finds the optimal policy for that trajectory offline. Now, what's of interest to us is with this theory, how can we steer user behavior based on performative prediction? We've given one example in the paper we presented at the poster session last night, but I think there's way more to do here with different types of actions, different types of goals. Now, I need to begin to wrap up. Yeah. The final bit under this part of the talk on pluralism, so many voices, goes back to a report that was published by the EU in 2019 after many, many years of preparation, and it makes the point for trustworthiness as a prerequisite for tech development. It identifies legal aspects, ethical aspects, and also technical aspects. The technical aspects in that report are called robustness. And well, to some degree, the report tries to go from principles to instruments, tries to go from just standing by the sideline to what does this actually mean when you build systems, when you deploy systems. So a distinction is often made in the setting between intrinsic aspects of trust, so that's revealing how a device works, what's going on inside the system, what's going on in the data preparation, in the data selection, what's going on in the result selection and presentation, and extrinsic properties. That's more like sticking thermometers into the system, different types of thermometers, and ones that are used a lot include those 5 that I'll present next. One is accuracy. So this is not just about leaderboarding, it's also about understanding where, under which conditions, and spelling out those conditions, you'll get that leaderboard score. It's also about reliability. What if I have different subpopulations? Do they all get the same treatment? What if I begin to violate some of the assumptions that I spelled out under accuracy? Does my accuracy drop by a lot, or what? Another has to do with something that a large part of our community has been looking at over the last years, right? Replicability, repeatability, reproducibility, different combinations of same team, same setting to different team, different setting, and seeing which of our results survive, which of our results do generalize and which don't. And it's great to see that we have more and more conferences that explicitly devote time and space for work that directly targets this dimension. I think it's super important. Resilience. So what happens if the world changes? What happens if our users change? What happens if our regulatory environment change? What happens if we go from a neutral environment to an adversarial environment? Do our systems still perform as well? Do our recommendations still make sense? Is our search still okay? And safety. Safety both of private data and of proprietary data. And so these are all dimensions that come out of this EU report from the high-level expert group on trustworthy AI. It's really a set of dimensions that calls for many voices. What is trustworthy, what is accurate, acceptable accuracy in one setting is not necessarily the same as acceptable accuracy in another setting. What is safe around medical data is not the same as what's safe around my Amazon data, etc. So this is really contextual, and hence it requires many different voices. But it's also not just EU. If you were in the tutorial on Monday on trustworthy ranking system, you will have seen that similar ideas have come up around the planet. China, Australia, North America, Europe. Not all of you might know that this is on its way. Truck. It's like track, but then for trustworthiness. There was a planning event in October last year. There'll be benchmarking activities coming to a location near you soon. This year, it'll be set up. Hopefully next year it will run. It will look at different types of trustworthiness in three contexts: employment, finding opportunities for people, computing matches between people and opportunities, translation, machine translation, and misinformation. Right, so let me wrap up this block. This was about many voices around the table, no centralized control. When you put tech out there, you should also address the impacts that your tech will have. Don't rely on policymakers or on society to fix it for you. And worry about more than just an accuracy-based leaderboard. Worry about other metrics. Optimize for different goals. So there you have it. This was the talk. Hybrid intelligence, about making AI. Shared ownership. This is not just for a select group of people. This should have participation from all of us. And it should be with many different voices. So what else? This was the slogan. We strongly believe in this. And I'd like to show in the final few minutes 2 or 3 examples of what we did to make this slogan more than just a slogan. So first, around hybrid intelligence. So we set up a hybrid intelligence center. Its purpose is, don't build systems as thinking machines, build systems as cognitive aids. We have plenty of really tough problems where we can use help. So that's what this center tries to do. Support research there. Augment people, don't replace them. We started with 30 faculty. It's a 10-year program. We're about 3 years in. We have around 30 PhD students and postdocs now. We're about to recruit another 20. If you are looking for an opportunity in this space, come talk to me. Second initiative, Innovation Center for AI. That's all about the shared ownership, developing research agendas, innovation agendas between these different types of stakeholders. A lot of learning by doing, so having the PhD students in this center work on site for part of their time with companies, with governmental organizations, in hospitals, you name it. We launched close to 5 years ago. Well, it's all organized around labs. Every lab has its own agenda. Every lab has 5 PhD students. We'll soon have 50 labs, 300 PhD students, 140-something partners. It's super decentralized. It's open science. It's mostly commercially funded, but everything is published openly. What we value most is co-productions between different types of stakeholders. Academic researchers, industrial researchers, folks in government, in civil society, co-productions, papers, data sets, benchmarks, you name it. Something that we just got funded that's specifically targeting many voices around the table is this robust program. It's devoted to AI-based trustworthy systems for sustainable growth. It has the same idea as ICAI, labs with PhD students, but now not just tech goals, not just economic goals, but also societal goals. So AI in energy, AI in food, AI in health, AI in mobility, AI in media. Since trustworthiness is so contextual, the lab setup that we have, I think, is a perfect fit for this. So it has technical people. Every lab will have technical people, socio-technical people. Well, we've signed up to quite a large number of the UN Sustainable Development Goals, and we're recruiting 85 PhD students. Come and join. So let me stop here. This is a look back. You have 3 things. Let's make AI for everyone. Making AI not to replace people. For everyone to participate. Pluralism from many voices around the table. Now, in my experience, wisdom has always been a very open community. And a lot of you are actually working on many of these aspects. And so please continue to do this. But if you're not yet, please join. There's so much to do. Thanks.